We're going to be discussing combinations of functions. That is, in this section, we're going to be given different functions and asked to find what we get when we say add the two functions or subtract the two functions, or maybe multiply or divide them. Okay, you always get some new function, but it is what you turn out when you do this. So let's say, for instance, I wanted to find f of x plus g of x, okay, which is what the whole intent of this video is in the first place. We want to combine functions, add, subtract, multiply, and divide them. Then what I can tell you is this. Let's start by saying let there exist some function. So we say f of x. We'll say f of x is x plus 4. And we say g of x. Why don't we call g of x is equal to 2x? What I want to do is this. I want to do these four things. Would you find, okay, these combinations? So we are going to find f of x plus g of x. We're going to find f of x minus g of x. We're going to find f of x times g of x. And we're going to find f of x, and we'll say divided by g of x. I'm going to write it this way, okay? So the interesting thing here is we can actually go find all of these just by direct substitution. What I mean by this is when somebody says, well, here are a couple of functions, and I want you to go find f of x plus g of x, what we're really saying is I want you to substitute the rule for f of x in for f of x. So we'd say x plus 4 is our f of x here, plus in parentheses we want to substitute the rule for g of x, which is 2x here, and say what do I get? Okay, so when you get down to situations like this, really what this becomes is just combining like terms, which I see that my x and 2x can go together. I get 3x, and then I would say plus 4. So we'd say, well, what is f of x plus g of x? It is this 3x plus 4. So now really quickly what I want to say is this. You'll see this notation also. But this is just a fancy way of saying when I added f of x plus g of x, I got a new function, and it's called f plus g of x, and that's its name. Okay, this is just a name. It doesn't mean that you're distributing an x or anything here. But it says this is some new function you got when you added f of x plus g of x. And so that's basically what I outlined up here. We say f of x plus g of x is some new f plus g of x, and we could say some new function h of x if you want to give it a name. But you basically directly substitute in the functions you were given. So now we were asked to find f of x minus g of x. According to me, all we need to do is plug in our function value. So we say f of x, which is x plus 4, and g of x, which is 2x. We'd say x plus 4 minus 2x. We can go ahead and drop our parentheses here, and we'll go ahead and combine like terms again. So I get negative 2x and a positive x is negative x. Say plus 4. This is our new function. We'd say this is f minus g of x. Okay, so this is our new function. So to finish this up really quickly here, we say multiplying. Multiplying would be very much the same thing. We say f of x times g of x. We're going to put in blank parentheses first. We say f of x is x plus 4, and g of x is 2x. So we could see that we could just distribute here, and we get some new rule. We'll call this f times g of x, and that comes out to be 2x squared plus, looks like 8x here. So we say some new function here. So far, combining functions is just pretty straightforward. It gets even best when you look at f of x over g of x, which would just be this. We'd say f of x over g of x. You just have to drop these in. You say x plus 4 is my f of x. This is f. And my g of x really is just 2x. So this would be it. And you could actually just stop right there. Stop. F of x over g of x is actually equal to this rational function right here, okay? So really quickly, what I want to do before we move on to the next video is this. I'm going to comment on what we mean by domain, okay? So we say domain. What is domain? Remember with a function, when we talk about values here, what we're really doing is we're plugging in x values and getting y values back. Or we could say that under some relation here, we are taking input or domain values. So these are our input values, and we're mapping them onto some output or range values here. So a lot of the time we are concerned with what are the domain values when you combine functions, okay? And the reason why is because sometimes you get domain values that don't give you back a y value. So it says the domain of a new function h of x consists of all the x values that were in the domains of the functions f of x and g of x. That is, when I made all these new functions over here, f of x had its own domain and g of x had its own domain, but the domain of this new function right here has to be only where the domains of the original functions overlap, okay? So I say it is important to note that in the case of a quotient or division, so this would be like our last example over here, we say the domain of h of x, that is the domain of the new function. So we got this new function x plus 4 over 2x. We say could not include any x values that would cause the denominator of the quotient to be equal to 0. That is, we couldn't put in any x values down here that would cause the basement to be 0. So as a question building into the next video, we say the domain of a function of x consists of all the x values for which the function is defined. That is, The domain is all x values that when you plug them in, say like 2 or just some x value, you always get a y value that it's paired with. There are sometimes going to be x values here that do not go to anything over here because it wouldn't be defined. So we say the domain is all the x values for which the function is defined, that you get a y value back. We say that is, if there's some function f of x or y, we say the domain will be all the x values that can be put into the function that allow the function to produce a real number y value, okay? So here's the question. Which x values, would not be included in the domain of a function? Which x values could you never include in the domain of a function because they would never go to a y value in an output? And we've already discovered one over here that we're going to go into in the next video, but what if I had an x in the basement? Is it possible that the bottom ever comes out to be 0? So for instance, down here we would say that you would not include x equals 0 in this new function's domain. And the reason why is because that would cause it to be 0 in the basement, which is undefined. Cheers.